So let's continue on our journey here and take a look at a whole bunch of other transformations. And let's see what we can do with this. I think it's critical, though, to remember what kind of function you're dealing with. So this square root tells you right away that you know and I know that this is going to give you this kind of fancy looking thing here. All right, now let's transform this. And in order to transform it perfectly, identify all these guys over here, your A, B, H's, and K's. So think about it. Your A, is a negative. Granted, it's a negative and there's no number there, but you know and I know that actually means -1. Inside the bracket here with the X, there's nothing. Well, actually, yes, there is something. It's a 1, remember? Okay, it's not a 0. Don't put down a 0 because 0 times X gives you 0 and then you got nothing, right? Your H value, are you moving anything horizontally? No. But our K value, oh, look at this. Well, let's bring that over to the other side. Oh, now I understand. Yeah, our K value is going down by 2. So our H value does nothing. Our K value goes by -2. So let's talk about this first. Let's talk about here. Let me clean this up because we need the room. Okay. So now that we have identified our A, B, H, and K, let's talk about this for a second. Let's look at the restriction on the X. You know and I know X has to be greater than or equal to 0. So you know that that means it's got to be going out that way. But with this negative number here and the fact that the A affects the vertical components, you know and I know just like parabolas, that means that this is going to be a sad parabola or opening down. In this case, in Math 30 technology or language, okay, terminology, I should say, in Math 30 terminology, we know that that's a reflection over the x-axis. That means this guy's going to be opening downwards. Okay, so we know we got a reflection there. So horizontally, there's not much going on here. Really, there's nothing, because look at our horizontal components. There's a horizontal component, there's a horizontal component. Nothing happening. But vertically, we're going to reflect, and of course, a vertical reflection is over the, yes, x-axis, all right? And this here tells us that we're moving down to. So what's our endpoint now? Our endpoint that started at 0, 0 now is being reflected downwards. Well, that doesn't affect any of the components. You know and I know that horizontally nothing happens to it. Okay? So we're still horizontally at 0. But vertically, we're going downwards by 2. So we have to move this guy down 2, and we're now going in this direction. So move down by 2. So I'm starting right there. And I'm going to be doing this beautiful reflection moving downwards. Okay, to add a degree of accuracy, let's look at our transform point, 1, 1 then. Okay, so what is 1, 1 doing? All right, horizontally, not a thing. Okay, so again, that's a 1. But vertically, multiplied by -1. So 1 times -1 is a -1, down 2. So this becomes -1, down 2. So our new point is 1, -3. Neat. Okay, so 1, -3 is right here, and lo and behold, that's what your graph is doing. Neat. Domain. X is still greater than or equal to 0 based on that restriction inside there. Okay, but our range now, look at our range. Everything below -2. So y has to be less than or equal to -2. What a neat question. Okay, so let's make it even a little bit more complicated. Look at this puppy right here. Whoa. Okay, let's look at the restrictions first, and let's see what's going to happen. Maybe we should identify the A, B, H, and K. All right, let's do A, B, H, and K first. There's the A. So we have a vertical stretch of 3. We have a B. Wait. Whoa, that's something wrong with that one. Something wrong with that one. Remember, to have a proper B, it has to be factored out. So that's not factored out yet. So in other words, we got to take out a 2 first. Leave that X by itself. And if we factor out a 2, that becomes -1/2. Oh, tricky, tricky, tricky question now, isn't it? Yes, it is. But can we still figure out the restriction here? Oh, absolutely. Look, 2x minus 1 still has to be greater or equal to 0. Bring the 1 over. 2x is greater or equal to 1. Divide by 2, divide by 2. X has got to be greater or equal to then a half. Aha! So interesting. So x starts at a half. Interesting. We'll talk about that in a second here. Let's keep on going. Okay, first things first. There's your b value. Your b value means it's a 2, but that, you remember, has to be flipped. So you're actually dividing by 2. And then our h value is an actual half, determined by our restriction. Ha-ha, interesting. So that's a half. What's our k value? Well, there's nothing outside here. This is not plus anything out here. So we're not changing the height of this at all, the starting point, okay? We're leaving it at 0. Okay, whew. Let's figure out where our new endpoint is. Well, our new endpoint, again, is based on how much you move this way and, of course, how much you move that way, right? There's a restriction which tells us our endpoint. So our endpoint is actually at 1/2 comma 0. Oh, okay, putting 1/2, that would be right around, oh, I'd say probably around there would be a good start. Now, so think of what again, if it asks you to describe the transformations, you have to tell me what's going on. So horizontally, what did we do? Horizontally, we moved 1/2 to the right, 1/2 right, okay? And we're also a stretch factor of, remember to flip it, we have a stretch factor of 1/2. Interesting. Okay. What are we doing vertically then? Well, vertically, we're not moving up or down, but we are, in fact, stretching our stretch factor vertically of 3. So how is this going to affect our 0.11 so that we can actually graph this thing and make it look cool? Well, remember, this is our x coordinates. Those are our y coordinates. So let's apply all the x coordinates. Well, stretch, reflect, okay? Then translate, SRT. So there's our stretch of 1/2. So 1 times this 1 here times a half is a half, okay? Plus a half move. So 1 times the stretch factor of a half plus the 1/2 move, okay? So you've got a half plus a half, which means it's 1, it's a whole. So at 1, there's our transform point. We're going to 1 comma, okay? Now, what's going to happen vertically? Vertically, well, it's not going to be moving, but you're going to multiply by a factor of 3. So 1 times 3 gives you 3. Look at that. Oh my goodness, your next point is 1 comma 3. So it's going to be way up here. And look at this new graph. It's going to stretch all the way out here and go out that way like that. Whee! Okay, cool, awesome. There it is. Domain. Well, domain now, based on the restrictions, got to be greater or equal to a half. And the range, well, you're still on 0 because, again, you didn't move, okay? Right? So the range is y is greater or equal to 0. Neato, neato, neato. Thing that you have to remember is this thing has to factor out that leading coefficient. You got to get rid of that 2 like I did here, and then everything else will fall into place beautifully. Got it? All right, last one. Last one. Let's see how well and efficient, and I'm going to throw everything at you in this question. Let's go. Whoa. Oh my gotcha. Check that one out, baby. All right, so here we go. I need all the room I can get. Remember, this is a radical function because there's that radical. So you know and I know it's going to look like that base formula or base equation. Now, let's identify our a's. Well, the a is easy. It really sticks out like a sore thumb there. There's a 4. But look, we got to factor this guy. We got to factor it. So take out a 2, leaving you an x plus 2 behind. Aha. Okay, great. So our b value, in fact, is 2. Our h value, remember, that is a plus 2. Normally, it's a minus there. So obviously, this has to be a movement left of 2. And then finally, what's this guy telling you? Well, do you still have to move it over to the other side, or can you actually see it by now? You know what? I know. You bring it over to the other side, it becomes -3. So when you see it as a +3 on that side, you know that this is going to be down 3, right? Okay. So what does this mean to our endpoint? Well, probably a good idea here then is to figure out what is the restriction. Figure out this restriction right here, 2x plus 4. Okay, 2x plus 4. There's an x. There we go. It's got to be greater or equal to 0. Bring the 4 over. 2x has got to be greater or equal to 4. Divide by 2. Divide by 2. X has got to be greater or equal to 2. It's interesting how that restriction, okay, shows up here. Oh, that's supposed to be minus. My apologies. It's interesting how that restriction shows up here. Isn't that neat how that they tend to be the same? Right? Don't forget. Let's do it. Okay? I'll show it to you again. Watch. Look at that restriction right here. Underneath the radical. You know and I know has to be greater than or equal to 0. Bring the 4 over. This is 2x greater or equal to -4. Like we said, divide by 2, divide by 2. X has to be greater or equal to -2. Notice that that is not flipped, because you didn't divide by a negative. You divided by a positive. Only when you divide by the negative do you flip that. And look, lo and behold, it does match. Interesting, 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 interesting. Okay, now let's keep on going here. All right, so where's our new endpoint? Our endpoint that traditionally started at 0, 0, where is it now? Well, basically, all you got to do is move it. Now, you're probably saying to yourself, well, wait a second. Don't you have to multiply it by A and don't you have to multiply it by B? No. One of the reasons why is because our original endpoint was 0, 0, right? So if you multiply the Y value by 4, well, multiply that 0 by 4. You get a 0. Multiply the X value by a half, because remember to flip that. Well, your original point was 0. Multiplied by half is still 0. The only thing that determines your new endpoint are these two values. So you're going to go left 2, down 3. Left 2, down 3 starts you right there. Okay, let's keep on going. So left 2, down 3 is our new endpoint. Wow. Okay, horizontally, what are we going to do? Remember what our horizontal factors are, B and H. Okay, so this is going to be a stretch factor of 1/2. This is also going to be left 2. Our verticals, stretch factor 4. Okay, and you're moving down 3. I think you're getting the hang of this. Now, using all of that idea, let's transform that point 1, 1. Why do we keep using 1, 1? It's the easiest point to translate and transform. Think about it. It's so easy. It's multiplying by 1. So let's go and look at the X values horizontally. BEDMAS tells us, SRTs tells us, stretch factor first. So 1 times a half is a half, and we're going left 2, which means subtract 2. So I'm at a half, subtract 2. Well, think about that. Isn't that just a -1.5, right? Isn't that just -1.5? Well, yeah, no kidding. So I'm at -1.5 for our first point. -1.5 for our first point. Then, now, let's go vertically. Stretch factor of 4. So 1 times 4 is 4, right? And you're going down 3. So 4, 1 times 4, down 3. So 4 minus 3, oh, that looks like 1. Oh, interesting. Okay, interesting. All right, so -1.5 and 1. -1.5 and 1 looks like it's about right there. And guess what? There's your new graph out that way. Isn't that neat? And you can see that it's really, really stretched. Well, yeah, no kidding, because, right? Domain. Here we go. Domain starts on your endpoint. Everything starts here at -2. So X has to be greater than or equal to -2. Range starts way over here at this bottom number that you determine here. So your range now is y's got to be greater than or equal to -3. And that's how you do these things. Wow, some really cool stuff.